Classes are the foundation of object-oriented programming. Object-oriented programming in itself is a very large topic, therefore we are not going to be able to cover all of the ins and outs in a single lesson. We're going to look at the creation of a simple class and work with it a little bit so you can start to get the feel for how classes work in Python. First of all, what is a class? A class is simply an arrangement of related data and the methods that manipulate that data. One of the simplest examples would be to create a class called person, and a person class would contain elements such as first name, last name, possibly social security number, could be any number of properties. The idea of a class is that it's going to emulate possibly some real-world object, and it also matters in the context that it's going to be used. In other words, a person in an application designed for the Department of Motor Vehicles may be a very different person than one designed for a school, for instance. Like for the DMV, a person would have a different type of ID number. They would have maybe their driver license number, the year that or the day that they got their first license, when the license expires next, what classification of license they have, and all of that may be part of the person class for the DMV. But at a school, you would have different information. This person may have a GPA. May be important to track date of birth, just like in the DMV. So there would be some overlap, but then again, there would be a lot of differences as well. So when we create the class called person, it really matters what we're creating it for. We're creating an academic person class. In other words, it's just an exercise. It's not one that we're going to use in any practical sense, just to get the feel for how classes work. As you could probably guess, there is a keyword called class, and we're going to create the person class. And just like every indented block of code, it typically starts with a colon on the previous line. So everything indented once from this class definition will be part of the class. There are class variables that we can define, and those are specific to the class itself, not to any given object. Now, what's an object? An object is a variable of the class type when you create one. So when you create a specific person, that would be an object of that person type. However, we can create variables that apply to all person objects, and let's just create something called person count, and we'll initialize it to 0. Now we'll use this variable to keep track of how many person objects we've created. Speaking of creation, we need an initialization method that will set up our class and create all of the object variables we will need to access. Now, object variables are sometimes called fields, and they are members of specific instances of our class. There is a special name for this type of initializer method, and it's init surrounded by double underscores. In other languages, this would be known as a constructor. Then we're going to provide the self parameter as the first parameter to this method. This is similar to this in other languages, and it's basically a way for it to reference the given object that it's being called on. We'll have a social security number, we'll abbreviate SSN, then we'll have first name, then we'll have last name. Now these are the parameters that we're going to pass to this special init method. And the interesting thing is, once we create the init method, you typically will never call it directly. There's a special syntax you use that will call this method automatically, and I'll show you that momentarily. Then we're going to define the fields that are part of this class. and we're going to assign all of the input parameters. I'm having interesting typo issues today. That's what happens when you lose the home row with your fingers. We'll set last name is equal to last name as such. So notice here we use this self object, which refers to the current instance of this class that we're referring to. So when we create this object, it's referring to this particular object, or the self object. And we're assigning it 3 fields. We have SSN, first name and last name, or 3 instance variables. And we're going to assign to those instance variables of this given instance the SSN, first name, and last name passed in to this initialization method, or initializer. Then we're going to augment the person count, because if we called this method from somewhere, that meant we created a new person. And we could set person.personCount plus equals 1. Now, the interesting thing that you may have noticed about this syntax is that I didn't use self to assign person count. I had to use the person handle up front. And this has everything to do with the fact that it is a class variable and not an instance variable like these 3. So person count to be accessed, we have to use the class name, which is person.personCount. When we start creating these objects, each individual person will contain its own individual SSN, first name, and last name variables, but there will only ever be one person count. It's kind of like a global variable, but it is inside this class, so it's scoped to the class. Now, another thing we could use this person count for is if we wanted to have maybe a primary key for this class that we'll save to a database somewhere that is not the social security number. Because for security purposes, it's always a bad idea now to ever save social security number in plain text. You just don't want to do it. So instead of using social security number, we could use the person count as the ID. So let me move the person count up top so the first one will be a 1, and then we could say self.id is equal to person.personCount. Now we can keep track of an individual ID of each person, and it will forever be growing every time we create a new one. That will be the next available ID as well. We can also create other methods in this class, and as long as we have a self parameter as the first parameter, we'll be able to call this method directly on one of our person objects. Let me say print hello self.firstName self.lastName. And let's put a period here. So hello, then it'll be first name and last name of this person. I better make sure I make that a lowercase l, otherwise it won't find that object or that variable. And this right here is enough to define our class. So we could hit run, and now our class is available to be used. So let's go ahead and create a new person. To create a person, for lack of a better variable name, I'm going to use P1. And we'll say P1 is equal to person, and then we'll pass in the ID, and then we'll pass in the first name and the last name. Now you'll notice there is one omission here. self. We don't actually pass the self object. That is something that Python takes care of for us. It knows we're calling this initializer by saying p1 equals person. This right here is what tips off Python what we're trying to do. This will automatically then tie these three arguments to these three parameters of this init function. Now we have a person. So we could call the methods that we created on this person, like print greeting. And again, notice here, we don't use self. That is done automatically by Python. It knows that it's going to pass in the current object by how we called it. Because it is a member function or a member method of the person class, and that's done with this self keyword here, it knows to take p1 and actually pass that in as self. So when we hit run, it'll say, hello, Bill Williams. Now, we could also make this class more useful by adding other methods other than just this print greeting. But before we do that, let's take a look at that person count variable just to prove that it did change. We'll say person dot person count. Remember, we have to use person dot to get at the person count class variable. We'll run that line, and you'll see the person count is now 1. We can also access any of the members of basically these variables, the ID, SSN, first name, simply by saying p1.lastName. Again, because p1 is the handle we're using in front of last name, it knows to get the last name of this particular person. We'll hit run, and there's Williams. And just to prove it, I'm going to create a second person. We'll call p2. We'll say equals person, and then we'll pass in a completely different set of data. We'll say Jill Smith, and then the person count should augment by 1 just by the virtue of the fact we created a new one. Actually, it's probably going to be 3 because I believe we ran this code twice. But let's go ahead and we'll say p2 equals person with this ID, this first name, this last name. We'll get the person count, and then we'll look at that person's last name. Okay, so it is 2 still. Run it again. Now it's 3. Every time we create a new person, so I did not run this particular code twice, which is fine. The interesting thing is, because that first p2 we created is no longer being referenced, Python's garbage collector will eventually get rid of that first one because there's no way for us to access it anymore. So even though, according to the person count, we have 3 of them now, one of them is no longer accessible. If I wanted to make sure I kept each one, I'd have to either put them in some kind of list, array, or separate variables. Otherwise, as I mentioned, they will fall out of scope. The garbage collector will take care of them eventually. So this person has a different last name than this person. So this one is still Williams. This one is still Smith. I'm going to cut this code and put it in a different cell so we don't end up creating too many objects. And I'll also move the greeting here. You know what? We'll call the greeting over on this one so you can actually see that. And let's change the greeting to also include the ID so we can actually see that they are changing. So self, or they're different for each person. So I'll rerun the class code. Actually, let me restart the kernel. That way we clear out all our objects. So we'll create the first person. Then we'll print the greeting and the person count and their last name. So it's hello Bill Williams with ID 1. Oop, probably don't need that extra space in there. Let's get rid of that. Restart that kernel for my changes to take effect. That's better. Okay, so back to P2 now. We create Jill Smith, and then we'll do one more print out. Oh, I should have been printing out P2, not P1. So you can see here the greeting for P1 is definitely different than the greeting for P2. They have different IDs. You can see that here, 1. And then the person count at the time that this one was run was 1, and now the person count is 2. If I rerun this block, this should say 2 now because it recognizes person count is now 2, and it does in fact change it to a 2. So this is the basis of working with classes. Very simple example, just a few variables, and right now it doesn't really do anything fancy. But what if we try to print this object, P1? What happens when we do that? Well, right now it just says it's a person class and it's sitting at this memory location. So it's not particularly useful to print this. However, when we print other objects like arrays and other things, you'll notice that it actually prints the data of the object and not this kind of ugly message just indicating the name of the class and where it exists in memory. And if we were to print P2 on a separate line, you'll see that they are in fact at different slots of memory. So they're both person objects, but they're different person objects. Okay, so how can we make this more usable? Well, the simplest way would be to add the str function. And because it is a special function like init, it's going to have double underscores, and we'll say str. And again, we're going to pass self to it. Now, whatever we return from this method will be what's printed when we say print this object, because that's what Python is looking for, is this special str method when you do a print command, and other things as well. It's basically a way for us to convert this object to a string. So we could say return, and let's use an F string. I think that makes the most sense because then we can format it. And we'll say self.id, and then maybe we'll put a colon, and let's put self.ssn, and then possibly self. Let's do last name. I think that probably makes the most sense when we're going to output this object. And then we'll do first name. So let's go ahead, and I'm just going to restart the kernel again just to make sure my changes stick. Okay, and then we will test it, creating a person. So all that code still works, but now let's do the print P1 and P2. Look at that. We have changed what the print command will do with our objects. Now, I'm one of those people that kind of like to have things line up, especially, when I'm looking at tabular formats of data. So I would typically go inside these this return F string here and change it so it uses justification for its values. Like for the ID, I might decide to right justify 5 digits. For SSN, let's just make sure it's let's just left justify it 9. Last name, let's left justify 15. And first name, we'll also do 15. Oh, that's right. Restart that kernel. So let's go step through it. Now I think that looks nicer because everything's lining up. So again, you use whatever you think is necessary for your application, but this is definitely a nice way to display your object as a string. But since we supplied the str method, now we can actually say s equals str and then pass it one of our objects. And then if we print s, this will also show the formatted string because the str function automatically again knows to look for this special str method of the class. Now, as I mentioned before, there's something called a garbage collector that runs in Python that cleans up the memory used. Remember, these objects are sitting at a specific location in memory, and at some point, your program could use so much memory it'll crash. These objects, you'd have to create millions of them before we had a problem. But if you had larger footprints or larger memory footprints in your objects, let's say megabytes each, then you'd want to make sure that you don't declare a lot of these objects at some global level. Like if you have just a long single method, like we don't actually have a method in our code. It's kind of all running within main. So all of these objects will stay active until the program actually ends. But if you declare a function and create the objects within the function, then when the function exits, those objects will be cleaned up by the Python garbage collector when it runs, which you don't directly have any say in the matter. You can kick off the garbage collector manually, but it's not a recommended practice unless you're really running into memory constraint issues. But we don't want to get too much into the detail about the garbage collector now, but just be aware if you wanted to get rid of these objects manually and you're done using P1 for instance, you can use the del command. Now if I try to print P1, you'll see that P1 is no longer defined. It has been deleted. So that is something to keep in mind if you want to be proactive and remove your objects when you're done. Now, in other languages, especially C++ and C for that matter, when you create variables that allocate memory, it's really on you to dispose of them properly to return the memory back to the operating system for use by other programs or even your own program. With modern languages like Java, C#, Python, all of those have garbage collectors which will automatically remove these objects from memory when they detect they are no longer being used. Each language has its own methodology for deciding whether or not an object is ready for disposal, but most of them have the ability to proactively delete them when you're done using them. Just be aware, once you do the del on any of the objects, all of its data is now going to be gone. So if you did need it for the future, you would probably have to recreate it again by calling the initializer like we did up here when we said P1 equals person. So that's going to wrap up this particular lesson. We are going to get in more detail with these classes in other lessons, but this right here is a good foundation for understanding how to create objects, how to use them, and then once you're done, how to get rid of them.